Okay, so now we're going to talk about mechanical advantage and friction. So sometimes the mechanical advantage is less than 1. And in the case of machines where the mechanical advantage is greater than 1, the machine is multiplying the input force to create a larger output force. If a machine has a mechanical advantage of less than 1, it is useful for tasks that do not require a large output force. So a bicycle is a machine with a mechanical advantage that is less than 1. Even though it has a mechanical advantage of less than 1, the output force causes the bicycle to move faster than the rider could walk, so that makes it a very useful machine. So the effect of friction. The difference between the calculated value and the real or actual value of mechanical advantage is friction. That is the force that opposes motion. So friction is caused by the roughness of the material. Because friction is a force in any device, the additional force must be applied to overcome the force of friction. So the mechanical advantage of a device will be less because of this added force that it must overcome. The speed ratio will not be affected. In fact, the speed ratio represents the ideal mechanical advantage of a machine, so as if friction didn't exist. Friction is a system that also causes heat, which can cause many other additional concerns. So now we're going to talk about efficiency. Efficiency is a measure of how well a machine or device uses the energy. The more energy that is lost, the less efficient a machine is. Efficiency is represented in a percent. So this is like when your mom says, I think you should be more efficient. That means she wants you to do more work, right? She wants to get more out of your day than you would any other day, right? Or you would on your own. So efficiency is the mechanical advantage divided by the speed ratio multiplied by 100. So in complex machines, there are many subsystems that also are affected by friction and other factors. So because of this, the most complex machines are not very efficient. So if you were to compare, say for instance, a wheelchair ramp versus an elevator, the wheelchair ramp would be more efficient than the elevator, given that they were going over the same distance. The basis of that is because the elevator is a complex machine, so there's a lot more areas that you can lose that energy. So no machine can be 100% efficient. So if you're doing a calculation and you get a percent that is 100% or over, you've done something wrong. You will need to go back and reassess your answer. Anyways, well, thanks for listening.